All right, so if you were following along with the last video, this one's going to be similar. So a stone is dropped from a 100-meter height. How fast is it traveling when it hits the ground to the nearest tenth? All right, so we are going to start with the fact that the acceleration due to gravity is negative 9.8. And I'm going to say 9.81 just out of habit. Okay, so then from there, what we're going to do is we're going to take the antiderivative of this going backwards, right? So the velocity function would be negative 9.81 times t and then plus c. So now we just don't know that c. So if we think about it, do we have any initial conditions though? And yeah, we do. At time 0, when t is equal to 0, then what's the velocity? Like what's the initial velocity when we drop this thing, right? So if you think about it, we've got some stone, and then we're just letting it go and dropping it. Well, if you think about it, right at the beginning, it starts at a speed of 0, or a velocity of 0. So we can say v is equal to 0 at the beginning, and then starts to speed up along the way, right? So our initial conditions would be 0 is equal to negative 9.81 times 0 plus c. So then c is just equal to 0. Okay, so our velocity function is just negative 9.81 t, and that's it. Just plus 0, so just that. Okay, so then from there, if you think about it, so we're looking for how fast is it traveling. So we do have speed introduced here now, right? Or velocity, but we don't know the time when it hits the ground. If we knew how long it took for it to hit the ground, then we could just plug that in and we'd be good. That would be the velocity right before it hits the ground, right? But we don't. So let's introduce. We do know that it's 100 meters high, so that's going to introduce height, right? So if we take the antiderivative of this, we're going to bring height into this. So the antiderivative of velocity would be height, and then this would become, and here, yeah, I'll do it in 2 steps. Negative 9.81 t to the power of 2, and then multiplied by 1 over 2, or just divided by 2. And then we just have left plus c. So I'll just simplify that. So height is equal to negative 4.905 t squared plus c. Okay, so now our initial conditions with this one. So at time 0, so I'm going to be able to throw in 0 for time. Then our height was at 100 meters. So let's do that. So we'd say 100 is equal to negative 4.905 times 0 squared plus c. That all cancels. So we get c is equal to 100. All right, so our height function is h is equal to negative 4.905 t squared plus 100. All right, so now I have a height, right? Like I can introduce the height, but so if we're looking at this, I can solve my time, right? So I can solve my time when I hit the bottom. And that's useful because remember, that was the problem up here. Like if I only knew my time, I'd be able to solve for my velocity. So the steps here is we're going to figure out the time to hit the bottom and then use that to figure out our velocity. Okay, so let's just solve this one now for time when our height is, well, in this case, yeah, our height would be 0, right? Because that's what we want. We want like our height to be like nothing. It's going to be right at the bottom. Now this might be a little bit confusing because in physics 20, sometimes we call this our height of 0, right? And then like below the cliff was like a negative height. But just by definition, we called this 0. This was our initial height. And then up here was plus 100, right? Okay, so hopefully that made sense. So the height we're going to say now is 0. So if we solve this, we've got negative 4.905 t squared, and then plus 100. So we'll bring 100 to the other side. So now we've got negative 100 is equal to negative 4.905 t squared. Divide both sides by negative 4.905. So we've got 100 divided by 4.905. They're both negative, so they become positive now, is equal to t squared. So then we'll just take the square root of both sides. So we get t is equal to, so we get it approximately equal to 4.515. We'll say. I'll just leave a few extra decimals. We want to round the nearest 10, so we'll just leave it like that for now. Okay, so that's our time. And then what we're going to do is we're going to go back to our velocity function and then just plug that in, right? So that was up here. So we'll say velocity is equal to negative 9.81 times, and then the number we just found, 4.515. And again, that should be approximately equal to, because we had to round that at that point. So V is approximately equal to negative 44.3, and then I'm going to write meters per second. Now, if we just think about it, the negative makes sense here too, right? Because our velocity is going to be going down. So if we didn't get a negative, you'd want to take a look at that.